Alright, Common Core Algebra 2, so our next lesson for Chapter 2 is going to be about finding slope and rate of change, which really are the same thing. So today we're going to start with a reminder of our definition of slope, talk about how we can classify that slope, and then we're going to compare the slopes of parallel and perpendicular lines. So to start, we're going to define slope in three different ways you could look at it. If we talk about it verbally, it's going to be the ratio of the vertical change to the horizontal change, or a lot of times we say the change in y over the change in x, because remember, if you think your axes horizontally is moving left and right, and that is your x, vertically is moving on your y-axis up and down, and so the change in vertical would be change in y over the horizontal change in x. Now, the letter that you guys have seen in the past has always been m. That's going to continue to be the case. And the formula, if you have 2 points, so this is our algebraic representation, would be y2 minus y1 over x2 minus x1. And those values come from 2 points. So remember, every point has an x and a y value. So your first point is just represented as x sub 1, y sub 1, and your second point is just represented as x sub 2, y sub 2. Now, it doesn't really matter whether you put 1 or 2 first, as long as whichever point you start with is the point that you start with on both numerator and denominator. And then finally, graphically, another representation will be, and a big one that we use a lot, is rise over run. Okay, that's another definition. And so we would figure out how far up do we go, and then how far over to the right we would go, or down and to the left, depending on what kind of line we're working with. So an example of finding slope, if I gave you these 2 points, I could tell you to find the slope connecting those 2 points, or the line connecting those 2 points. Now, we could plot those 2 points on an xy axis and find how many up and over we go, or if we were to do it algebraically, we plug it in this way. So y2 minus y1 is going to be negative 6 for y2 minus 3 for y1 all over x2 minus x1 negative 4. So be careful, negative 6 minus negative 3 is going to give us negative 9 over 4 minus a negative 2. Remember, minus a negative becomes plus, and we end up with 6. So you could leave it as negative 9 over 6, or I'm going to reduce that. Since both are divisible by 3, I'm going to end up with a slope of negative 3 over 2. Okay, so that's how we find slope, and 3 different representations of it. Now, classifying slope, there are 4 different ways that slope can exist. It can be positive, it can be negative, it can be 0, or it can be undefined. A positive slope is when we are rising from left to right. And you see here a blue line. This has positive slope because you can think of this as rising or going up from left to right. A negative slope is when we do the opposite. We fall from left to right, and so our line will fall. It's like coming down a hill there. And those two we usually do pretty well with. The ones we forget about are when we have 0 or undefined slope. So 0 slope is just anytime we have a horizontal line. And this is always going to be y equals some number. There is no slope, or it is 0, the value 0, because you see here our rise over our run, doesn't matter how far left and right we go, our rise is always 0, so we don't gain anything. Undefined slope is going to be a vertical line, and you'll see here that's because now our run is 0, and so we'd have something over 0 and we can't divide by 0, so we say it's undefined. The equation of this line is always going to be x equals some number. And then finally, our parallel versus perpendicular lines. So remember, parallel lines are 2 lines that are always parallel. They're never going to touch each other. They're never going to intersect. And the big thing that we're going to need to remember here is that parallel lines have equal slopes. Likewise, comparing then, perpendicular lines are 2 lines that intersect at 90 degrees, like here, and that's what that box means. And they have slopes that are opposite reciprocals. So real quick, going back to parallel, I could say these are both positive slopes, so maybe we have a slope of 2 over 3. If I know this line, the L1 has a slope of 2 over 3, then I know L2 must also have a slope of 2 over 3 because they're parallel and they are equal. Now the opposite reciprocals piece, what we want to add here, if we know that the slope of L1, it's negative, so I'm going to say negative 2 over 5. And I'm just making that up. That may not actually be the slope. An opposite reciprocal would tell us that L2 here would have to be flipping this value, so that's the reciprocal piece. I write it as 5 over 2, and then because the opposite, this is negative, we want to take the opposite, this one's going to be positive. So the other one would have to be 5 over 2. One other thing to add here is that opposite reciprocals always multiply to a negative 1. So we can just take the reciprocal by flipping it and making it an opposite sign. If it starts out negative, it'll become positive. If it starts out positive, the opposite reciprocal will be negative. And that is it for this lesson. Big thing there, remember slope. We talked about it in 3 different ways. Rise over run is the one that we typically remember the most. Our letter that we use to represent slope is m. And we've got our equation, which was y2 minus y1 over x2 minus x1. We classified slope, which there was 4 different kinds: positive, rising from left to right; negative, falling from left to right; 0 for horizontal lines; and undefined for vertical lines. And then finally, parallel and perpendicular lines. Parallels have equal slope, perpendicular have slopes that are opposite reciprocals. We'll see you next time.